This is the third in a series of videos on the subject of configuration management, or CM, designed to provide a grounding in the subject and to allow those of you who are either about to start doing development or have recently started to understand what it's all about and how important it can be to projects. In our last video, we looked at architecture and planning, and how modern CM tools can be used to define and capture technical requirements and structure your requirements into time boxes. Having recorded everything that needs to be done and worked out a project plan, we now come to the next stage, starting the actual development. Developers are usually grouped into teams of varying sizes, depending on the project, and while a project manager or their team will guide and monitor the overall project, it is likely that the allocation of work is done by a team leader or Scrum Master. The requirements management system may have an entry that reads "Provide login screen for user," requesting both username and password. Associated to this single user requirement may be a collection of technical requirements, detailing the database used for the authentication, the table containing the user's details, and what specific rights the user has in the system, their user type. If this is a SQL relational database, there are likely to be schema definitions of the table and the stored procedure called to authenticate the user. Once a selection of requirements are parcelled out to the development team for the first time box of work to be started, developers can then begin their work. We spoke in a previous episode about starting a project that had never been worked on before, building from scratch. However, even in such projects, developers are likely to use libraries of code to save time during development. The use of such libraries is why developments can progress quickly. Why spend valuable time reinventing the wheel when someone, possibly yourself, has already created suitable code and put it in a library with the intention of code reuse? This library of code will also have been tested in previous projects and has a known performance. The next thing to examine is where do developers store this code. While the writing of code is done on desktop or laptop computers, just having a copy on a single machine is risky. Any single computer failure or accidental file deletion would likely put your project behind schedule. So we now need to look at version management systems. A version management system, or VMS, is a code repository. Think of it like a library for code. New entries can be added to the library, and existing entries can be checked out and updated before being checked in again. Over the years, there have been many types of version management systems, but probably the most popular one now is one called Git, initially developed by the same person that created the Linux kernel. Git is a distributed system for which there are a range of client applications, and files are stored in Git repositories or repos. There are two types of Git repositories: remote and local. A remote repository is hosted on a remote server. This could be on the internet or an off-site server. It could even be the same machine in a different path, and is shared amongst multiple team members. Local repositories are on your own computer. The advantage of a VMS like Git is that each developer has a complete history of every revision ever made on every file. So they don't need to be online to a central repository to be able to develop. Plus, when committing files back into a repository, it records who made the change, when it was done, and the reason or comment the developer added. A good system will also allow you to connect the files you have added or changed to the reference of the entry in the requirements management system. This allows other interested staff to see what was changed for each requirement, as a single requirement is likely to have had many files associated with it. The requirements management system, or advanced issue management system, can also be used to mark a requirement as having completed development, allowing it to become a build candidate. There will be times in a project when 2 or more developers need to work on the same set of code files. Unlike in a book library where checking out the same book to 2 students is a problem, it's not necessarily an issue with a modern version management system. Multiple developers can work on the same file at the same time. When those developers attempt to check the changes back in, the version management system will alert them and attempt to merge the changes into a revision containing all the changes they have made. However, there will be times when this is beyond what the system can cope with, and developers will need to cooperate and manually amend code to ensure that the functionality of the merged file or files is what is wanted. As you can guess, each developer will attempt to unit test their code to ensure it meets the requirement. This may involve setting up a test area on their own computer or server, and is usually done before the code is checked back into the version management system. Checking in untested code is generally frowned upon, as it risks the integrity of the codebase and project. As each developer completes their assigned pieces of work, the requirement entries for the time box being worked on will be marked as having completed development. It's likely that you would have a continuous integration process set up to periodically pull files from the version management system and build your project. This would be part of an automated build management system, which is the topic for our next video. That's it for today. Thank you for watching.
Thank you for watching today's video. Please feel free to click on the link in the description below to discover more videos.